Hello, we're going to talk about the periodic table today. Um, you guys have had an opportunity to sort through some cards, kind of like Mendeleev did, and see how he used different patterns to put things together. But let's take a little history. Johann Wolfgang Dobereiner, in 1829, sorted the known elements into what he called triads, groups of three. John Newlands, in 1865, noticed that when you listed out the elements by mass, similar elements were separated into intervals of 8. I think he even used the term octaves at one point to compare it to music. Mendeleev separated elements by their chemical properties and then ordered them in order by their mass, and he would leave spaces if something was missing. And then Glenn Seaborg, developed the modern periodic table.
In 1869, a Russian chemistry professor named Dmitry Mendeleev was writing a textbook for his students when he began to wonder how he could best explain to them the 63 elements that were known at the time. To help formulate his thoughts, he constructed a card for each element. On each card, he wrote the name of the element, its atomic weight, its typical properties, and its similarities to other elements. He then laid the cards out like a game of solitaire and began arranging them over and over, searching for patterns. Then came the moment of discovery. Before him was something extraordinary. The elements fell into 7 vertical groupings. Each periodic grouping had members that resembled one another, both chemically and physically. Mendeleev had discovered the periodic table of the elements, a map showing how all the elements related to one another. A map so precise that Mendeleev believed he could also use it to predict the existence and properties of 3 elements no one had yet discovered. One would be like boron, he said, one like aluminum, and one like silicon. Eventually, the elements were discovered, and Mendeleev was proven right.
There was actually a little bit of controversy because a German chemist named Lothar Meyer had come up with roughly the same idea. But Meyer didn't quite have as much courage. So that's actually an interesting thing. Here is this German who comes up with the same idea of periodicity, of which there were hints already before, but he doesn't make the predictions that Mendeleev does. So here we see the power of a risky prediction in having people accept a theory. There is nothing more powerful than making a prediction that's not obvious.
And then have it come true.
The periodic table is our icon. I mean, that's what we associate with chemistry. You go into any chemistry room, you see it.
Why is the periodic table of elements significant? It forever changed the way that everyone would learn and understand the elements. The periodic table of elements is to chemistry as notes of music are to a Beethoven sonata. In honor of Mendeleev, his name is now literally attached to the periodic table. The element 101 was named after him. It's called Mendeleevium.
It's not only chemists who like the periodic table. I hear you carry one around.
I do carry one, yes sir.
Show me.
You never know. And I seem to use it a lot.
Let's see.
It's a small one.
So I'm going to give you a test. What is under nitrogen in the periodic table?
Nitrogen is 7.
Yes.
I have to think a second.
Under
Sulfur.
nitrogen. Oh, you're wrong.
Oh, God. So
Close.
I carry
You're
the thing.
one off. It's phosphorus.
Oh, phosphorus.
Phosphorus
15.
is right.
Phosphorus is 15?
Yeah, you have to add 8 at that point.
See, that's why I carry it. I can't remember. So it's 7 plus 8. 15 phosphorus. Okay. There's a pattern there.
So this is a rendering of what Mendeleev's early periodic table looked like. If you look, you can see here we have lithium, sodium, potassium. We've also got copper thrown in there and silver thrown in there. But things that we know today are in that first group, and so on and so forth. You can see some things that are in the same spot and some things that are not. Now, Mendeleev arranged by mass, but today we use atomic number. That's because there are instances, for instance, iodine and tellurium, where if you look at tellurium and iodine, tellurium's mass is actually greater than iodine's. Yet, tellurium comes ahead of iodine on the periodic table. If you put them in mass order, iodine, who has lots of properties in common with bromine and chlorine and fluorine, would be in the wrong column, and tellurium, who has things in common with selenium and sulfur and oxygen, also would be placed wrong. So, that is why we use increasing atomic number. The periodic law states that when the elements are arranged in order of increasing atomic number, there is a periodic pattern in their physical and chemical properties. Periodic means a pattern, something that happens in a regular interval. When I was first teaching, we didn't have search engines on the internet. We had encyclopedias. And when you went to the library, you would go to the periodical desk to request magazines. The Reader's Guide to Periodic Literature, somebody somewhere read all the magazines and kept track of different articles, and they would publish it monthly. So there was a little red pamphlet that you could find for the month previous. And then once they got 6 months together, they would bind that all together, and then they would have them by years. So that was one way to do your research, to look for magazine articles. You went to the Reader's Guide to Periodic Literature, and if you were doing an article on Saturn, you would look Saturn up. If there weren't any articles that last month, you'd go to the month before. That is how it used to work in the old days, and they called it the Reader's Guide to Periodic Literature because magazines come at regular intervals. My Time magazine comes every Saturday. My Discover magazine comes once a month. Days of the week are another example of things that are periodic. When you look at the periodic table, you're going to see the name, the element name. You're going to see the atomic number, which is the number of protons. You're going to see the atomic symbol, and you're going to see the atomic mass. Now that mass is different than the mass number we have been talking about. The mass number we talk about is a specific atom. This mass number is an average of all the different molybdenum atoms that are out there. So here is an atomic, this is a different one, just has the symbol, mass, and atomic number on it. This one, there's an atomic mass up here. You've got some measurements there, the symbol, and some stuff that goes with electrons. Here, this periodic table gives you information about the type of phase or state that the element is in at room temperature or standard temperature. All right, that is all for now. We will get started with some more of the good stuff next week. Thank you very much.